8 ते 6च्या मध्येच तुमचे लॅब्स प्रॅक्टिकल वगैरे असतात.
अदरवाईज 24/7 चालूच राहतं लॅब वगैरे.
नाही, आता कसं आमचं तिकडे आहे ना बाहेर, तर 24/7 नाही ठेवलं आहे त्यांनी लॅब चालू. लेकिन अगर स्टुडंटची रिक्वेस्ट असली तर मग लॅब चालू ठेवतो आम्ही. आणि आजकाल म्हणजे कम्प्युटर सर्वांकडेच असते. आमच्याकडे 2च ब्रांचेस आहेत, ते कम्प्युटरवालीच आहेत. तर त्यामुळे असं काही आवश्यक
करायचं स्टार्ट.
Welcome you all. Very good morning. Now we are starting with the first session of day one for this 1 week activity. Now we are having first session by Dr. K.D.K. sir. So the topic of today's presentation is CNN and RMN for medical image. I request sir to kindly start the session.
Okay, thanks.
Thank you.
Yeah, so once again, I welcome all the participants for this particular workshop. So we will start initially with the CNN, that is a convolutional neural network, and then later on we will look into the RNN, and then there are certain hands-on that I have. Let's see how much I am able to cover it, right? So these are the contents that we have for the CNN exclusively, that is a neural network, why deep learning is required, and then the deep models exclusively CNN, and then the application of deep models. So we'll start with the neural network because it is the advanced version of neural network, right, which is called as a deep convolutional neural network, or CNN we can say, right. So we'll go with the one example. So as you know, this is a neural network, right. So in the neural network, you are having the input layer and there is output, and in between that you will have many hidden layers, right. And all the neurons are connected to all the neurons in the successive layers. So that is the ideology behind neural network. So when we take this particular ideology, so with this ideology, it will going to consider the input as a single vector. Okay, it will consider the input as a single vector as per the figure, and we can have the input as a two-dimensional as well. That is not a big deal, right? And then there are many hidden layers. The job of hidden layer 1 and hidden layer 2 in this case will be, so hidden layer 1, they are made up of set of neurons where each neuron is fully connected. So that fully connected is really the hurdle for neural network. Okay, when you are having a neural network, and with the neural network, that is a basic neural network, because they are fully connected, in between you can able to see there, and where they are having a one restriction. Okay, the restriction is single layer function completely independently and do not share any connection. That is exactly the hurdle in a neural network, right. So you can able to see, let's say hidden layer 1, you see the first top neuron. Okay, that neuron is taking the data from previous layer, processing it, right, as per the formula, and then it is passing to the next layer, that's all. But whatever that has been computed, it is not utilized. That is exactly independent. So due to that, if you are processing some image on the neural network, it will going to take lots of neurons. It will going to take lots of what we can say training time, and your neural network itself will be very, very complex. That will going to happen. So we'll see with the help of example. So here, so the last, and later on the last fully connected layer is called as the output layer, and where the classification will going to happen. Okay, so in the classification there will be some score is generated. Based on that score, I can categorize the particular data or the particular instance, okay, belongs to which particular class, class A, class B, or whether it is spam or not spam, something like this, right. So this is the ideology which you all aware about. But the problem in the neural network that we want to see, then only you can relate really when I have to use a deep neural network, that you can think for, right. So this is the statement I'm making over here. The regular neural network doesn't scale well to full images or large images. So I am moving from the traditional data, which is a textual data or the numerical data, to a image kind of data. So in that case, okay, a small image I can process from neural network, no issue. But the moment, because scalability has to be there when the big images are there, so at that time the same neural network must work. Okay, and how, what are the changes that need to be there, that we will see. So this statement I'm making, wherein I'm saying that the neural network is not good for the images when you are scaling the images or you are going for a large data. So I'm taking a simple example over here. This is the data set which you might came across while performing or using the neural network. So CIFA are 10 images. Dimension is 32 cross 32 into 3. That is it is a RGB image, right? Having a 3 channels. where 32 is a width, 32 is a height, 3 is the color channel. So now this is your input, right? So for this, we will analyze the neural network, and for this we will analyze the deep neural network, which is CNN. Okay, how the changes, how means the parameters calculation is there, right? So if you consider the single fully connected neuron in the first hidden layer of neural network, it will going to have this many weights. Okay, there we have to calculate this many weights. 32 into 32 into 3, 3072 weights. That's fine. Okay, this number is not that big, so that is fine. And this amount can be manageable, but clearly it is a fully connected structure. The moment I increase the size of image, this will drastically increase. Okay, it will drastically increase. So how that change will be? Take an example. I just increasing the image. So previously image dimension was 32 cross 32. Now the image dimension is 200 cross 200. Okay. So most of the time, if you are working with the CNN, the image size you will going to get this 200 plus, because most of the standard neural networks, like let's say it is a VGG 16, VGG 19, their dimensions are 331 cross 331 or 229 cross 229. It is more than 200, right? So if I'll take an example over here, so how much weights now I have to calculate when it is a simple neural network? 120000. So just little change in the input dimension, that many weights I have to calculate, that many parameters are getting evolved, and that I have to process. Okay. So complex. So if this dimension I'll increase once again, let's say my image dimension is 1024 by 1024. When it is a geospatial image, that time 200 cross 200 will not very much important. Geospatial means it is taken from large distance. So your image has to be a bigger in size, 1024 or bigger than that. So in that case, definitely neural network, I can it will fail in terms of more parameters, in terms of more processing, and in terms of more training time. It fails, but it will going to give result. But you have to wait for longer amount of time. That is there, right? And moreover, we cannot all the time we cannot say that I'm going to get a good results, because number of parameter lead to overfitting. आपके पैरामीटर्स अगर बढ़ गए तो ओवरफिटिंग इनविटेबल है, वो आना ही आना है. Okay, so that is the thing which we can learn out of the neural network. But moving toward deep neural network or a convolutional neural network or connet, which is something like this, which you can see in the right hand side, where the first layer, the first figure indicates the input dimension, and the next from that we are extracting the feature, then we are extracting the feature, and then we are extracting the features. So if you look into this, the input dimension at a particular point is this much, right? Then the feature extraction will happen with the help of CNN, which is a convolution layer, which will going to have some filter dimension, 3 cross 3, 5 cross 5, 7 cross 7. What it does, it revolves around that particular image, extract the prominent feature, and those will be given to the next layer, right? So that is an opportunity where we are able to reduce the number of parameters from one layer to another layer. Okay, that we'll look into. So in the neural network which we already seen, there we are having a three things, and in uh, unlike neural network, in convolution neural network we are having a three things: weight, height, and depth. Okay, so whatever the image dimension, it is a one parameter, which that is a weight is a one parameter, height is another parameter, and depth is another parameter. So with these three particular parameters, what we are keep on performing the operation on the particular image. So what is the operation? Feature extraction, nothing else. We are doing the feature extraction, and due to that I am going to get the feature something like this, and at last only one neuron or two neuron it will be land up in that particular way. So here, if we take a same example that we took for neural network, right, where my image dimension is 3 cross 32 cross 32 cross 3. So here, as per the CNN or the convolution neural network, width will be 32, height will be 32, and the depth will be 3. So this is the representation, right? So it will consider in that way, and then the neuron in the layer will only be connected to small regions. That is the change in a CNN and the neural network. Neural network में what happens? You will going to have 32 into 32 into 3, that many neurons in a input. ठीक है, ये इतने सारे न्यूरॉन है. Then they will be get connected to some another set of neurons, right? So उससे ज़्यादा ही रहेंगे, because in the hidden layer I have to keep on performing the operation, and उसमें you will going to have more number of neurons as compared to the input. Then only you are able to extract prominent features, because what it is something like a fully connected network in computer network, and like mesh network hota hai जो fully connected है, when it is taking feature from here and there, and then only it is passed on to the another one. But here what it does, only small portion, that means only one of the small portion will be there, and from that it will extract small thing, and likewise it is keep on reducing that entire input, okay, to a prominent feature in the form of one or two neuron at the last layer. Okay, so small region of the layer, and instead of for the neurons of fully connected manner, which we have already seen. So here participation is with respect to region wise participation. Okay, on the region there will be a filter applied, that filter will give you the prominent from that particular region, then another filter prominent from that, likewise it is reduced. So there we are not able to see all the neurons from input are connected to all the neurons in the later stage. Only part of the neuron will be worked upon, and that particular what we can say projection will give you only one neuron. Okay, so this group will give one, then this is another group will give one, then another group will be give one. So in that way, here there is a drastically reduction of parameters. Okay, and that is exactly the opportunity for us to use CNN for image processing. Okay, CNN for image processing, and at last output layer will have the dimensions which will be depending upon what you want to have at the last. So as this is a CFIAR data set having a 10 classes. Okay, इसमें 10 classes है. So for that, the output dimension is a 1 into 1 into 10. So it is a 10 neurons at last. So first neuron will talk about the first class, second neuron will talk about the second class, and that will going to get with the help of by using some particular what we can say the softmax function, which will going to do the probability. So that probability will land up with one particular class, and there it will going to declare yes, this is, let's say, digit 1, let's say it is a digit 2, let's say it is a digit 3. So in that way, so that entire dimension, so dimension we started from this, right? This was the input dimension, but it is landed where? So we are extracting everything, and we are reducing, and we are coming toward at last end where the classification score will be available, and that classification score will tell this particular data which is the input belongs to which class. Okay, belongs to which particular class. So this is exactly the head-to-head difference which you can see in terms of neural network and deep neural network, which is a CNN in this case. So this gives the opportunity. I'll take another example. Okay, suppose the input volume has, so if you talk in terms of numbers, so it gives more understanding, right? So another example I take over here, it is a RGB 32, and let's say we are talking here in terms of filter size. Okay, I have not talked on what exactly a filter size, we will discuss later on. But when we are at this particular page with respect to dimension 32 cross 32 cross 3, which is my input, how that particular input is what we can say reduced in terms of the prominent feature by applying the filter dimension of, let's say, 5 cross 5. Okay, so I'm making one 5 cross 5 filter. Okay, that filter will be applicable on 32 cross 32 into 3. इसके ऊपर अभी ये revolve होगा. Okay, I am having a figure, so by that you will get more and more understanding. So each neuron in the convolution layer will have the weight to 5 cross 5 into 3. तो जो आपका input था 32 cross 32 into 3, by applying the filter dimension of 5 cross 5, okay, it is getting reduced to 5 cross 5 into 3 after applying CNN layer. Okay, so you can see there is a drastic reduction. So यहाँ पे parameter बहुत ज़्यादा थे, but यहाँ पे it is very less, which is only 75 neurons, right? And likewise, and there will be a one bias element. So plus bias is getting added. So 75 plus 176. So in that way, so filter decides how much reduction will be there on the particular input. And likewise, you can have many such convolution layers. Okay, and the job of that convolution layer is to extract the prominent features. So एक बार one form of, if we are having a first CNN layer, so it is having some good feature, then on top of that another CNN layer, you will get some more another good features, likewise. So at last there will be a reduction of that particular input dimension into 10 neurons. Okay, so here by this you can easily understand the filter size make a impact. So notice that the extent of connectivity along the depth axis must be 3 since the depth of the input, since this is the depth of the input. So here whatever the depth we have, it is a 3, right? ये आपकी depth है. We'll take another. So by this figure you can easily understand. Okay, so here this is more elaborative. So now this is a 32 cross 32 image, right? This is a 3, that means RGB. It will applicable on all. Okay, so उसको applicable करने के लिए आपके पास कम से कम 3 filter होने चाहिए. One filter will apply on R, one filter will get applicable on G, and another one be on blue, RGB. So 3 अलग अलग filter रहेंगे. Then they will revolve. So see here, this particular portion will give you 1 neuron. Okay, then likewise it is getting revolved. So this particular dimension will be something like this, then reduced to something like this, and at last you will going to have only 10 neurons. So this is the concept which is with respect to CNN. But in the right hand side, the figure which I have shown, that is related to neural network. Okay. So in the neural network, all the input dimensions will be get considered. Okay, and here there is a weight and there is the input are getting multiplied and the bias are getting added, and here there will be some activation function is applied and the output is generated, right? So so here how much input you will going to have? 32 into 32 into 3. Okay, that everything will come here and then it will produce one output. Similar, like, so you can assume that how much complex that your artificial neural network when you are processing images. Okay, but if you will consider this, here it is a one particular portion of 5 cross 5 consider, so it is a 25 neurons, right? The 25 neuron will be get compressed to a one neuron. So there the dimensions are getting reduced. So that reduction happens. So all features you get at last, and at the trailing end you will going to have some dense layers so that you can do the classification. That is exactly the ideology. So this particular figure, it is the basic figure of neural network, right? But this particular figure is the part of CNN. So after 3 CNN or 4 CNN you will going to apply. At last I have to do the classification. In classification we can do only by the dense neural network. Okay, so where 2 or 3 layers will be there, they will do classification. They will jumble everything. When you jumble everything, then only you are able to decide, okay, the potential of all the details that are available in terms of neuron. And then we will going to the classification where softmax function or logistic regression you will going to apply, and you can going to have the probability, and that probability will speaks about in which particular class the instance belongs, right? Because this particular neural network will take some particular input as an instance, and this is the model which you have already designed, right? Yeah, this is another example. My input dimension is different now. Okay, so this is not the start. This dimension is not at the start. At the start your dimension will be 16 cross 16 into 3. इससे ज्यादा नहीं हो सकता है, right? आपका ये color image ही होगा, right? So it will going to have 3 what we can say dimensions. Now it is a 20, that means this particular dimension it is in between. Okay, ये in between वाला एक dimension है जिसके पहले आपने CNN लगा दिया है, right? So you got this 16 cross 16 into 20. Now here I am applying the convolutional neural network of the field, the receptive field or the filter dimension is a 3 cross 3. ठीक है, इसके ऊपर अभी मैं 3 cross 3 वाला लगाऊंगा. So with that what it says that as previous slide, 3 cross 3 and whatever the what we can say the channel 20 channels है, 20 channel पे 3 cross 3 लगेगा, right? So that 3 cross 3 will remain this into 20, it is 180 connection. Okay, so in this way we can keep on increasing the filter dimension or keep on decreasing the filter dimension as per our requirement, and there we are able to extract the features. So after that यहाँ पे आपके parameters बहुत ज्यादा है, but when you are applying this, so your parameters are getting reduced to 180. Okay, so in this way the composition will be there. So once again here we notice that the connectivity is a local to 2D space, that is 16 cross 16 is a 2D space of 3 cross 3, but a full along with the depth of 20. That 3 cross 3 in the 2D space will be applicable to all the 20 channels. That is the meaning which we can refer from that first 2 points. So I think you got a little understanding, right? See how the what we can say, the features that are extracted, there is the parameters are getting reduced. That is the one opportunity. But when your image dimension itself is very very large, right? So that time sometime we are also using some another functionality which is called as a dropout, which you might have heard. So we are dropping certain features, they are not relevant, and for that we need not to bother what to drop. We have to just tell us that 20% मुझे drop out करना है. So intelligently that particular model will drop out 20% in that particular. So there also reduction of